Would you believe me if I told you that orcas will fly through the sky, collecting crucial data about climate change and improve our ability to see into the future? Not those orcas. ORCAS is a field research project funded by the National Science Foundation that will use an NSF NCAR aircraft with special instruments on board to take measurements from the atmosphere and the Southern Ocean to get a clearer understanding of carbon dioxide exchange. To demonstrate what we mean, let's go over the basics with a bottle of soda. What does soda have to do with cutting-edge climate research, you may ask? When you pop off the top, bubbles start to rise. Ever wonder where these bubbles come from? They come from carbon dioxide gas that has been dissolved under pressure in the liquid. Gases can dissolve in liquid and are dependent on the chemical nature of the gas and liquid, or solute and solvent, temperature, and the partial pressure of the gas above the liquid. The scientific law that explains this is Henry's law. The dissolved carbon dioxide stays in the soda solution in the closed soda bottle, where the partial pressure was initially set high during bottling. High partial pressure means more carbon dioxide will go into the liquid solution. When the bottle is opened, the partial pressure above the liquid decreases, allowing the carbon dioxide to come out of the solution, causing a noticeable hiss. Temperature of the liquid matters as well. Less carbon dioxide is absorbed when temperature's warm, and more is stored when temperature's cool. But Henry's law doesn't just apply to soft drinks. It comes into play on a global scale. In fact, a quarter of all anthropogenic carbon, that's carbons that humans produce, gets absorbed by the ocean, acting like a big storage reservoir, commonly called a carbon sink. And that brings us back to orcas. The Southern Ocean is unique. It's where the world's oceans meet, poleward of 30 degrees south and surrounding Antarctica. It's where deep ocean water upwells to the surface, allowing CO2 exchange with the atmosphere. Some say we know more about the surface of Mars than the Southern Ocean. What? The ORCAS campaign will help to change that, advancing research in the area about its role in the carbon cycle, the larger climate system, and the state of its ecosystem as well. What are some of the effects that carbon dioxide exchange in the Southern Ocean has throughout our world? We rely on the oceans to uptake carbon dioxide that otherwise greatly increases greenhouse gases in the atmosphere. But CO2 uptake in the ocean also means that the ocean's pH level is lowered. Higher levels of acidity can in turn threaten oysters, clams, sea urchins, corals, plankton, and all calcifying organisms that rely on calcium carbonate to produce their shells. When shelled organisms are at risk, the entire ocean's food web may also be at risk. There is also some evidence that the ocean's absorption rate of carbon dioxide may be becoming less efficient. One simple reason for this is the fact that as CO2 is dissolved into seawater, there is a growing resistance to adding still more. Deeper surface water mixing would increase carbon dioxide uptake, but if there is less mixing as a result of surface warming, more carbon dioxide remains in the atmosphere, creating a feedback loop. What's a feedback loop? It's when a change is self-perpetuating, creating a repetitious cycle. For example, warming leads to more water vapor in the atmosphere, which in turn leads to further warming. It's a vicious circle. That leaves us with the ocean's thermohaline circulation to discuss. It redistributes ocean waters all over the world based on their density due to salinity and temperature. Much of the water that reaches the surface in the Southern Ocean has been submerged for hundreds of years. When that water is exposed to CO2 at the surface, its temperature, salinity, carbon dioxide, and biological activity make an enormous difference in how much carbon dioxide will be exchanged between atmosphere and ocean. All of these processes are crucial to advancing our understanding of the role the Southern Ocean plays on our planet and improving climate and Earth system models. ORCAS scientists will indeed be flying from up high to just above the ocean's surface to collect oxygen and carbon dioxide measurements that will allow them to infer how much carbon dioxide uptake is occurring and what processes are responsible. And while flying killer whales may look pretty cool, they would be hard-pressed to accomplish all of that.